Forks. Luckily for us, the chrome on this is actually in very good condition. There's no pitting that I can see. Maybe a fraction up here, but the area where the fork travel is, it seems fine. So pretty unusual, but I think we won't bother getting these re-chromed. It's not worth it. The other bikes I have, definitely I'll need to get it re-chromed. You can buy new fork stanchions. They're $400 each, so pretty expensive. So it's probably cheaper where possible to get them re-chromed. So all we're going to do is strip this apart, replace the fork seals, probably the dust caps. They've started to break down a bit. The springs inside are pretty old. We're talking 1986, so they may have well collapsed over the years. So I've got some new springs, and we'll replace the oil, and we'll clean up this aluminium finish. Probably won't polish it so it's shiny silver. That's wrong. It just needs to be a sort of dull, I suppose, aluminium finish, but we'll get rid of the corrosion and scratch marks. Maybe even give it a coat of clear to stop it from corroding back again. Yeah, so let's pull it apart. You can see here, these have got like a Schrader valves. So just make sure there's no air left in the fork. Probably not. Oh, there's a tiny bit of air, but not much. So what we've got to do is depress this down a bit against the spring, and you can probably just see there's like a circlip. There's a steel ring that we need to just flick out and then gently release without it smashing itself in the face. Not much pressure on these. They're pretty easy to depress. So hopefully we can just hoik out the spring. There we go. That's the top cap. I'll have a look at the O-ring and see if that needs replacing. Spacer. You can adjust the length of these if you want to put a bit of preload on. By adjust, I mean make up some spaces to make them longer or shorter. And we've got a washer. And then I think we've got the spring. The oil came out quite clean, but this last bit is like black sludge, so it's probably separated. You can see that black oozing out, so it's probably just, like I say, hasn't been mixed up in years. So this will need a good clean, and obviously we'll replace the oil. So just looking at the spring, some springs can be wound tighter in one direction, but this looks to be, from my eyesight, one of those springs that just has equal spacing all the way along, and it's not conical or anything like that. So really this can go in any way, it doesn't matter. There's no, from what I can tell, no orientation on it. So now we can just prise off the dust seal. Like I say, it's pretty degraded, so definitely need new ones. Just the plastic's got hard over the years and it's beginning to crack. Okay, so next up we've got to remove the bolt in here. There it is. So that came out quite easy. I used a little electric impact drill just to make things a bit easier. Obviously there's a copper washer. We'll need to replace that. Actual bolt is in very good condition, so we'll reuse it. Next up is just remove another clip in here just by levering it out. Now the bit I never like, and that is getting this seal out, and you use the action of the fork as a slide hammer. So what we do is just jerk out the top stanchion. Now this can happen, and that's why I don't like it. So it started to come out, but the bush has come over the top of the seal. So it nearly came out, so we're going to have to just lever it out with the screwdriver. So that's the fork seal. There's a spacer, and this bush and that's what came over the top. So they've got a small split in them, and you can see it probably just expanded and came over the top. So that sits on this top edge. It'd be good to get new ones. I've been searching for new bronze bushes online and I can't seem to find any, so if we can't find any, then I'll have to just reuse these. And the last bit to come out is this damping rod. So that's the bit that bolts into the bottom of the fork. So that was like that. Okay, so we'll clean up these parts, just wash them out with a bit of Caro, and I'll have to order some seals, but in the meantime I can clean up the bottom of the bottom fork leg. We'll remove this bolt, which is just a drain hole, and get a new one. Yeah, so now it's just a case of cleaning up, making it look good. So as you can see, I've buffed this up, so I've got rid of all the pitting, but the other thing you can see is super shiny. It's too blingy, which is not characteristic of this sort of bike. It needs to be sort of like an off or matte silver. Just with weathering and aging, I think they look like this, but definitely it wouldn't be a mirror finish coming out of the factory. One thing I could do is possibly shot blast it with a glass bead. That would take the edge off. The other thing is you can get aluminium sanding blocks to give it a brushed aluminium look. The other thing I accidentally found out is engine degreaser like this stuff. This has got like sodium hydroxide or an alkaline. It's an alkaline base degreaser. Aluminium doesn't like it. Yeah, I would never wash the bike in this stuff because it causes aluminium to sort of like go grey, it gets a grey bloom, I suppose you call it. I think it just attacks the aluminium and ruins it. So I wouldn't recommend, like I say, sort of doing this. It's a bit risky because if you don't wash it off properly and quickly, and I'm saying really quickly, within 5 minutes, you'll get white ghost marks everywhere, like drip marks. But what I might do is, just as an experiment, give it a quick wash down with this stuff, allow the reaction on the aluminium surface to take place, and hopefully it'll give a grayer bloom or grayer finish to the aluminium. So like I say, you've got to be quick. So I just got some made up in a spray bottle. Okay, and I'll just quickly wash that off before it dries. Okay, I don't know if you can see that. We'll compare it between the two, but it's sort of taken the gloss or the shine off it, and it's just beginning to sort of go dull. Like I say, you've got to be really quick. You don't want any like drip marks. To me, that's still a bit too shiny, so I might give that another couple of coats. Yeah, it's still a bit too shiny there, I think. Let's see how it goes. Well, after all that, I actually put it in the sandblaster and just blasted it with glass beads. And I think, to be honest, that's much more of a factory finish than the polished look. Yeah, and it's also a lot easier to do, no need to buff. So comparing it to the original, which has got this sort of very grey, not very glossy look to it, is a lot closer to the factory finish. Still going to put maybe a lacquer on it, just to seal it off and to give it a little bit of a shine. But overall, I'm quite pleased with that. It's sort of come up quite well. So I'll do the same for this one. So we've stripped down the forks as much as we can. I've cleaned out all the old oil. There's a lot of sludge in the bottom, so we're almost ready to reassemble. And obviously we're going to put new fork seals in and new oil. But one of the other things I want to try and do is there's a modification we can do on old style forks like these, because to be honest, you know, Japanese suspension from the 80s compared to what we've got now isn't particularly great. Modern suspension is now using USD or upside down forks, which are much stiffer, and they have a lot more clever internals in the fork to allow better compression and rebound damping, and also you've got the ability to apply preload, which is good. Now, we don't want to, you know, some bikes from that period people replaced or swapped out with more modern forks, but we're trying to keep the bike looking more original as much as we can from the exterior, so we can play around with the interior, which we can't see. And one of those mods is a thing called PD valves, which are these. I bought these, they're made by, you know, the same mob that I bought the springs from. They're $100, so not too expensive. And you get obviously the pair, and they look like, the best way to describe them is like a spinning top. But the way they work is, it's like inside here is a metal washer that's sprung loaded, and it allows oil to flow obviously through in two directions. Now, the only thing they can do, I think, is, and I get this model up, I'll probably have to correct myself, is you can only set the compression damping. It won't change or impact the rebound damping, meaning that obviously when the fork compresses and pushes oil up through this valve, you can adjust how much spring load it is on a washer here, like an aluminium washer, to restrict the flow, which is what you're trying to achieve. You're trying to play around with the speed of flow or the damping to absorb your bumps. Obviously, too much damping, the suspension becomes really wooden, almost solid, and you get your front wheel bouncing over the tops of bumps, which is what you don't want, and you get like almost a skittering effect as you go around the corner and you hit a bump and your suspension is not following the curve of the bump, and that's what you don't want. And when the tyre is in the air, it's not in contact with the ground and you can crash. So they're clever little, very clever little design. Obviously the other problem, well I say problem, is you have to play around with how much spring load you're applying to that washer. More spring load, the more resistive the washer is to open, and less spring load allows the washer to come up more easily and allow more oil to flow through. So let's just take one apart. They have a little lock nut at the back. Before we do anything, as these have come from the factory, just measure this. The best way I think is to measure this height, which is, it's about 23.4. That's, don't need to be too accurate. 23.4 mil. So we know when we reassemble it, we can put it back to how it was. So there's a little lock nut at the back that just needs to be, when you adjust it, you need to obviously slacken this off, adjust it, and then tighten that back up. So we'll just remove that. It's just a little nylock nut, so it won't vibrate loose. And now you can adjust this by winding it in, and you put more load onto this washer, and you can obviously unwind it to reduce the tension. And what happens is, if you can imagine, there's oil can flow through these little orifices, and as the pressure builds up, this is a bit easier. As the pressure builds up, you can just see in there that the washer, or this, I'm calling it a washer, this disc is allowed to come up, and then the oil will flow through. And then in the other direction, when the oil wants to come back the other way, there's just a very lightweight disc here, which has got a very gentle or very low spring on it, so it allows the oil to flow back very rapidly through in that direction. So it's sort of like a bit of a, you know, restrictive valve that way and quite an easy flow in the other direction. We can unscrew all this all the way out. So that's that little washer that goes up and down. In fact, it's got a little hole in it, probably to allow at very low speed a bit of flow to come backwards and forward. And then in here, it's difficult to see, but oh, it comes apart, that's good. There we go. It's just a very soft spring in here, and then a little spring steel washer, and then the orifices. So that goes in there. And then we get our screw, put that back on there, tighten it up, check the height again, so we're at the same level. So that's set, and then once you've set it, screw this back on, Just tighten it up so it doesn't move around. There we go. So that's it in principle, but where does it go on the bike? Well, as you probably know, this is the damping tube and does all the work. And that will is fixed to the outer fork, so that slides. So you put it in here, slides all the way down. And then you bolt this to the bottom fork or outer fork tube. So that's bolted on there. In fact, I'll draw this so you sort of get an idea. So you imagine this is the lower fork, or what's the name of it? Stanchion, lower stanchion. And your seal would be in here. Imagine that like that. So this is bolted or sandwiched in there, so this can't move, this damping tube can't move. And obviously as your bike goes down the road, this is going up and down, and there's oil in here and there's oil in the tube. So the oil, when you hit a bump and the fork compresses, the oil in this cavity has only really got one place mainly to flow, and that's through these two holes in here. So the oil would go in there and then sort of flow up the tube, and then you get equilibrium. That's what you're achieving at the end of the day. Now at low speed bumps, it's very slow movement, the oil can easily get through the hole in a fluid way. But if you hit a bump really hard, the actual flow rate is it's not linear. It's something to do with fluid dynamics that I don't want to go into. But what happens is the faster you try and force oil or fluid through a hole, the force to do that is exponential. It's not linear. So by that I mean, how can I do this? We draw a graph and we've got, I don't know, the flow rate this way and then the force this way. Instead of being like a linear line, the more flow, the more force. It actually goes sort of like that. Maybe that's a bit exaggerated. So what that means in engineering terms, I think, is this hole size diameter will tend to work really well in a narrow band. So at very low rates of flow, the oil is not doing any damping effect at all. And then at any really high velocity or pressure, it's actually restricting it too much, and you get wooden feeling. So in effect, this hole is designed to sort of try and be in the sweet spot for most average riders in most average conditions, which probably is not great, given that I'm quite a heavy rider. I'm like maybe 100 kilos, and road conditions are very different. We're not riding all on the same smooth tarmac. Some road conditions are really bad. So this is where this little thing can come in. So if I take this apart again, so what we're going to do here is this will take over the job of doing this hole, and it sits up the end here, and the oil goes in through here, up through the tube, and then obviously comes out here. Will then hit this PD valve here, and the spring will have a much more better range in damping. So for us to get rid of this, I suppose, bottleneck, is you actually need to drill this out bigger, much bigger than it would be normally. And in fact, we have to not only drill that out bigger on both sides, they recommend putting another 2 holes here as well. So I'll take some video just basically making this a lot bigger. And you want to, where you can possible, make a chamfer, nice chamfer, to allow the flow to be nice and smooth as much as possible. So we'll put a big chamfer on there. Don't touch any of these holes, because these are probably for low speed flow or oil flow. So don't touch those. And it just works on the lower end of this damping rod. Yeah, and one other mod we have to do, unfortunately, is because this is sort of like almost like a universal product, it needs to cover or seal the end, and because of this little lip here, it's not locating in this hole very well, or not at all actually. So we're just going to have to make up a washer to cover the end, because you don't want it when you assemble it in the tube, you don't want it offset too much. Whoops, don't drop that. Yeah, you don't want, I mean, that's exaggerated. What would happen then is the oil would just simply bypass this valve and not do any work. So we want to make almost seal this end off and allow the oil just to go through the end. Anyway, you see what I mean when I'll machine up a little disc a bit later on. So hopefully that's explained the principle, and we can then adjust this to get compression damping just as spot on. And once we assemble the bike, we can only do it when we assemble the bike, I'll show you a rough way to sort of get the compression and preload about right. So that's that.